Hello students, welcome to my channel eScience. In the last class, we have discussed about the physical properties of acids, bases and salts. And now today we are going to discuss about the chemical properties and some indicators like synthetic indicators, how to identify the acids and bases with the help of the indicators we are going to discuss. Okay, so before going to the topic, so subscribe my channel and press the bell icon. If you like the video, you can like and share the video. Okay, so let us go to the topic, indicators. Right, in the last class we discussed about natural indicators. Now we are going to discuss about the synthetic indicators. Synthetic indicators, right? So what is meant by indicator? Already we discussed yesterday, right? So indicator means what? Indicator is a compound which show a change in the color or smell. That is, indicator is a compound which shows a change in the color or smell. Okay, so if the indicator prepared artificially by using the chemicals, that is called as synthetic indicators. If the indicators are available naturally, they are called as natural indicators, that we have discussed, right? So synthetic indicators means indicators which are prepared by the chemicals, right? So there we are having two types of indicators. One is methyl orange indicator. Methyl orange indicator. One is methyl orange indicator, and one more is phenolphthalein indicator. Phenolphthalein indicator. Okay, so these two types of indicators are there in the synthetic indicators. And how they show changes? As indicators are what? Indicators, they show the change in color or smell. And how they show the changes in the acids and in the bases, that we will discuss. Okay, right. Methyl orange shows that red color. It gives red color in the presence of acids, and it gives yellow color in the presence of bases. Red color in the presence of acids and yellow color in the presence of bases. That is, actually methyl orange is an indicator which is having a light yellow color. Just we can call it as pale color. Okay, and this indicator, when you add in the acid, that is in the presence of acid, that color changes to red color, and it is when in the presence of base, it changes to yellow color. Okay, right. Now phenolphthalein is an indicator. Again, it is a synthetic indicator, again which is having the no color. That means how the water is there without any color, so same like the same color will be there for the phenolphthalein. When the phenolphthalein we have taken in the presence of acids, that is when we are adding to the acids, this phenolphthalein shows no color, that is no color change will be there. Okay, and the phenolphthalein when you are adding in the bases, that shows a dark pink color, or you can call it as purple color also, dark pink or purple color. Okay, right. What methyl orange indicators and phenolphthalein indicators. Methyl orange and phenolphthalein, these are the synthetic indicators. And yesterday we discussed, in the previous class we discussed natural indicators. Their natural indicators, we have what? Litmus paper. We have litmus paper, red litmus and blue litmus paper we are having over there. Yes, right. Red litmus in the presence of acid, that do not show any change, and in the red litmus in the presence of base, that shows blue color. And blue color when in the presence of acid, that shows red color. That is, the color changes to red. Blue color to red color it changes, and the blue litmus in the bases, that will not show any color. So these are the main basic indicators to identify the acids and bases. Okay, so methyl orange, phenolphthalein, red litmus and blue litmus. Okay, now let us having a topic. Suppose we'll take example, right? We are having the three samples, A, B and C. Three samples I have given you. Just imagine three samples I have given you. Okay, A, B and C. Let us say A, B and C. So in the three of the containers, we are having the three solutions called A, B, C. Right? We don't know what is the samples, but we know that what one acid is there, one base is there, one neutral is there. Neutral means that is not having acidic properties, not having the basic properties. Okay, so that is what three samples are there, A, B, C, but we don't know what is what. And you are given with a red litmus paper. You are given with a red litmus paper. Then how can you identify the three samples by using only one red litmus paper? That is our topic, right? So let us discuss. Suppose you assume three samples are there. We are having only red litmus. Now we'll take the red litmus paper and we'll dip in the sample A. We will dip in the sample A. Okay. Just you assume the red litmus is not showing any color change. The red litmus is not showing any color change, right? So red litmus not changing color. Okay, what is happening here? Red litmus not showing any change. You see this? Red litmus is not changing the color in the presence of acids. Yes or no? Red litmus in the presence of acids is not showing any change, right? So this is what, this is maybe acid or neutral. Why? Because in neutral also no color changes will be there. Whether the red litmus, whether blue litmus, anything you take, there is no color change will be there. Okay, so this first one is might be acid or neutral. Okay, now same again we'll take the red litmus paper. Why? Because here that is not changing the color, right? So that we will change, we will take into the B. We'll take into the B. Just assume that if the red litmus it changes to blue color, if the red litmus changes to blue color, okay, now what happens here? Now what happens to red litmus changes to blue? See this, red litmus changes to blue in the presence of bases. Just now we discussed, right? Red litmus changes to blue in the presence of bases. Red litmus changes to blue in the presence of bases. That means this B must be what? It is a base. It is a base. Okay. Now we are having what? We are having the blue litmus paper. That blue litmus paper again we will dip in the container C. Again it is not showing any change. It is not showing any change. That means it is not showing any change means that may be neutral. Not may be neutral. Right? If the blue litmus is changing to red color, if the blue litmus changing to red color, it might be acid, but it is not changing color now, so it might be neutral. Now again we will take the blue litmus and again we will dip in this first one. Again second time we are dipping in this. Firstly we have taken the red litmus. Now when we keeping in the blue litmus base, it has changes to blue. That blue litmus now we are taking in the container A. Now the blue litmus in this container A, blue changes to red. Blue changes to red. Blue litmus is there. That is we are dipping in the container A, that is changing to red. Blue litmus changing to red in the presence of acid. That means in the container A, what is there? Acid is there. What is there? Acid is. That is in container A, acid is there. In container B, base is there. In container C, neutral is there. Okay. Same thing we can do with the blue litmus also. Yes or no? Right. So that is what identifying the unknown samples by using the indicators. This is clear, no? Right. So let us discuss chemical properties of the acids, bases and salts. Okay students, let us discuss chemical properties of acids and bases. Okay. So chemical properties, what is meant by chemical properties? So chemical properties means how the acids and bases they react chemically, means how they are reacting with other chemicals. That we call as chemical properties. Physical properties means what? How they react physically, how they are appear physically. That is physical properties. Okay children, let us discuss chemical properties of acids, bases and salts. Right. First of all, what is meant by physical properties? Till now we discussed on how they are physically, how they physically appear, right? So these are called as physical properties. Chemical properties. What is meant by chemical properties? That is how they react chemically with other chemicals, how they are reacting. That we are called as chemical properties. Chemical properties, right? Let us discuss the chemical properties of acids and bases. Okay, so first one is what? Acid with a metal. First is acid with a metal. How the acids are reacting with metals. Okay, so generally in our daily life also we can listen some words in our houses, right? So that is what, not to store the pickles in the metal containers, right? And not to store the curd, right? Any source substances in the metal containers, right? And we seen many of the people are using copper bottles, right? So the copper bottles, which are in the copper bottles, they are storing what? Lemon juice, lemonade they are storing. After drinking that, they may get some problems. Have you observed that? Right. So that is what is happening over there. Why they are telling to not to store the source substances, acidic substances in the metal containers. Right? So that we are going to discuss here. That is, they will write a general reaction for this, right? So whenever a acid is reacting with a metal, acid reacting with a metal, will get a salt and a hydrogen gas. Will get a salt and a hydrogen gas. Whatever the metal we are taking, that correspondent salt we will get. Okay, right. Let us take an example here. So just imagine we are having a container here, that is a conical flask is there. In that conical flask we have taken the zinc granules, right? So for this I have added some amount of HCl. I have added here. What is the zinc granules are there? I have added HCl, right? After adding HCl, we will observe that some bubbles are arising, some fumes are arising over there. Yeah? So that is what the zinc is reacting with the hydrochloric acid. That indication is that. Right? So after adding that HCl, we can keep a a single hole rubber cork along with a delivery tube. We can keep for that, or else without rubber cork also we can take. So at this delivery tube mouth, at this mouth of delivery tube, you can take a burning mastic. If you take a burning mastic, that mastic will make a pop sound. That mastic will make a pop sound. That is, the mastic will put off by making a pop sound, a sound like tup, right? So that is what is happening here. When we are taking the zinc granules in a conical flask, for that we are adding hydrochloric acid. That hydrochloric acid reacting with the zinc granules, some reaction is going over there, that you can observe there, that is releasing a gas, and that gas is reaching through the delivery tube, coming outside by the delivery tube. At the mouth of the delivery tube, if you take in a burning mastic, that mastic will put off, by making a pop sound. Pop sound means a sound like tup. Okay, so that indicates what? Some gas is evolving over there. That indicates a gas is evolving over there. Which gas is that? What reaction is happening over there? That we will write here, right? So acid is there. Which acid we have taken? HCl we have taken, and metal, zinc metal we have taken, right? So here what happens? Hydrogen gas evolves, no? So directly we'll write hydrogen gas. Hydrogen gas evolves in this reaction also, right? So I'm writing hydrogen gas. Okay, hydrogen gas. Salt is there. We don't know the salt name. How to write the salt name? I will tell you now. Okay. So it's simple thing. Here how many hydrogens are there? Left side, one hydrogen is there. Right hand side, two hydrogens are there. So I will make it the balance. So here two hydrogens are there. So I'm writing here 2. Now you see this two hydrogens removed, no? Right, two hydrogens removed. What is there here? 2 chlorines is there. Why? Because the coefficient 2, it belongs to hydrogen, and the coefficient 2 is also belongs to chlorine. That means 2 hydrogens are there, 2 chlorines are there. Okay. Now hydrogens already removed. Remaining what is there? two chlorines are there, right? We can write a formula here, ZnCl2, zinc chloride, okay, right. So if you take one more reaction, same, in the place of acid, we'll take one more acid. We'll take a H2SO4 plus zinc again, H2SO4 plus zinc. Now it is very simple, right? Why? Because here already H2 is there. We'll take directly as H2 gas. Right? The upward arrow mark indicates gas. Yes or no? Right? Gas indicates, and plus ZnSO4. ZnSO4. So why we are writing like ZnSO4 only? Why we are not writing like SO4Zn? Because that is a rule is there. That is, while writing the names of the compounds, we should write the metal as a prefix and remaining part as the suffix. So metal in the first and the remaining negative part in the next. Okay, so that is ZnSO4, right? But remember one thing, children, hydrochloric acid will react, H2SO4 react, but HNO3 is reacting, but it is not giving the hydrogen gas. It is not giving the hydrogen gas. Why HNO3 is not giving the hydrogen gas? First of all, what is HNO3? HNO3 is a nitric acid. HNO3 is a nitric acid. That nitric acid is not going to release the hydrogen gas. Why? Because HNO3 is a very good oxidizing agent. It is a very good oxidizing agent. That the hydrogen forms in the reaction, that hydrogen is oxidized by the HNO3 and forms water molecule. Right? Just remember, whatever the hydrogen gas, generally what happens, whenever acid react with metal, they produce hydrogen gas. This acid reacting with the metal and produces hydrogen gas. So let us write here HNO3 plus zinc. Right? So we will get what? H2 will get, and write ZnNO3. Right? So here what happens, this H2 will be there, no? That H2 will be oxidized. H2 will be oxidized to form H2O. Why? Because here number of molecules will involves. So we'll get here 2Zn, here 2ZnO3, and number of molecules increases, so that it will form like what? Water molecule, that is hydrogen is oxidized. Okay, so that is with HNO3 this reaction is not possible. Okay, so that is what acid with a metal reaction. Reaction we called as acid with a metal reaction, right? So because of this reason, what is happening here? When an acid reacting with a metal, we are getting a salt and hydrogen gas. That means metals, they react with the acids to produce hydrogen gas. So that only the people are telling to not to store the source substances or acidic substances in the metal containers, right? So why? Because the metal containers may react with the acidic substance, like pickle you are taking, right? So the pickles contains what? Some acids, right? So they may react with the metal containers, so that they are telling to store in the ceramic containers or plastic containers also you can use over there, but not to store in the metal containers. So that's why you see the whenever you go to any shop in a supermarket, you can see the vinegar, right? That is acetic acid, that available in the plastic bottle only. It is not available in any metal bottles. Right? Suppose cool drinks are there, they are also available in the glass bottles, right? So, but they are not available in the metal containers. Next we will going to discuss acids with metal carbonates and metal hydrogen carbonates. In the previous lastly we discussed what? Acids with metals we discussed, right? Now we will discuss about acids with metal carbonates and acids with metal hydrogen carbonates we will discuss, right? So first of all we'll write the general equation. Okay, so what is the general equation means? Just I'm writing like this. We are taking a acid, any acid you can take, plus a metal carbonate. So this type of reaction we call it general reaction. We are not mentioning any particular acid, any particular metal carbonates, that we are not mentioning over there. So this type of reactions we call it general reactions. Okay, so acid with metal carbonate will get a salt plus water plus carbon dioxide gas we will get. Okay, so which salt will get? The correspondent metal carbonate. Which metal carbonate we are taking, that correspondent salt we will get. Okay, so that how we are getting, that we will discuss, right? So for that we need a apparatus, we need a setup like this. So first of all we'll take a boiling tube. We'll take a boiling tube. In that we'll take any one metal carbonate, any one metal carbonate. Here I am taking Na2CO3, sodium carbonate I am taking. Sodium is a metal carbonate, sodium carbonate, metal carbonate. So metal carbonate, and we need to take a acid, right? So after taking like this, we need to arrange a double hole rubber cork. We need to arrange a double hole rubber cork. In one of the hole we need to insert a thistle funnel. We need to insert a thistle funnel, and in another hole we need to insert a delivery tube. We need to insert a delivery tube. Okay, so now we need to add a acid through the thistle funnel. We need to add the acid through the thistle funnel, right? So now we are adding a acid. Which acid we are going to add here? We will add H2SO4, sulfuric acid we are going to add, right? Now first of all what we have taken? We have taken a boiling tube. In that, so remember how we are writing and how we are conducting the experiment. So that is also important, right? So first we will take a boiling tube, then we will take sodium carbonate, that is any metal carbonate we are going to take. Then we are keeping a double hole rubber cork. In one of the hole we are keeping thistle funnel, in another hole we are keeping a delivery tube. Okay, so from the thistle funnel we are sending, or we are passing the H2SO4. We are passing the H2SO4. As soon as H2SO4 reaching the sodium carbonate, you can observe that some effervescences are coming, that is some fumes are coming. That indicates the gas is evolving, right? While the gas evolving, we'll observe the gas is going through the delivery tube. Then immediately we'll take one more boiling tube or any test tube, which is filled with lime water, Okay, so lime water formula is what? Calcium hydroxide. What happens with the lime water means that we will discuss. Okay, now this is the experimental setup. Again remember, firstly adding sodium carbonate, closing with the double hole rubber cork, then adding thistle funnel, adding delivery tube. Through the thistle funnel we are adding the acid, some gas evolving in the boiling tube, that is reaching coming out by the delivery tube and reaching to the lime water, which is in another boiling tube or another test tube. Okay, then what is happening in that we will discuss here. Okay, so let us write the reaction. Acid is there, no? Which acid we have taken? Sulfuric acid, H2SO4 plus metal carbonate. Which metal carbonate? Na2CO3. What is happening over there we don't know, but we know what? Salt, water, carbon dioxide, right? So let us, we don't know the salt, no? Water we know, right? So write water as it is and write carbon dioxide as it is. So you see here once, here H2SO4 is there, Na2CO3 is there. Okay, so this H2, and from the CO3 one oxygen is taken by the H2, then H2O, then here what will be remains? CO2 will be remains. That CO2 comes here. That means this H2 and CO3, they both are coming out in the form of H2. From here one oxygen, H2O, that is H2O, and here CO2 will be there, CO2, that is CO2 gas. What is remaining over there? Na2SO4, and the salt is, we need a salt, no? That is Na2SO4, right? Now hydrogen gas evolved, carbon dioxide gas evolved. What is that? Carbon dioxide gas evolved. Then why we have taken this calcium hydroxide, that is lime water? We did not use it in the reaction, no? That is to test the carbon dioxide. We are telling what? Some gas is evolving in this, we are telling, right? But how to identify that gas? In the previous experiment what we have done? Pop sound comes when the hydrogen releases, pop sound comes in the presence of when you're taking a burning matchstick, that will put up by making a pop sound. That is the indication. Pop sound coming means that is hydrogen gas. Then here carbon dioxide gas is there. How to identify the carbon dioxide gas? That is when we are taking the lime water, that is when we are passing the carbon dioxide into the lime water changes into milky white. This will changes into milky white. The color changing, the milky white color changing indicates that presence of carbon dioxide gas. Then what is happening over there, right? So we are passing the carbon dioxide into the lime water, right? So carbon dioxide we are passing into the lime water, that is they both are reacting now. Okay, now what is happening here? So see this, Ca is there, Ca, CO2 is there, and here OH taken twice is there, CO2 plus from here one oxygen, that is releasing like CaCO3 plus here one oxygen removed, one more oxygen will be there, H2O, that is H2O will be releases. That is the formed compound in this another boiling tube, that is CaCO3 after changing into milky white, that is what? Calcium carbonate. Calcium carbonate. Okay, right. So this is what when an acid reacting with a metal carbonate, this thing is happening over there. But when a acid reacting with metal hydrogen carbonate, what happens? Same products will forms over there, that is salt plus H2O plus CO2 only will form. That is when an acid reacting with carbonates and when acid react, that is metal carbonates, and when the acid reacting with metal hydrogen carbonates, the products are same, that is salt, water and carbon dioxide gas. So let us write a reaction here. So we'll take here Na acid, right? So we need acid, so I'm writing acid here, HCl will take, and metal hydrogen carbonate we want, no? So I'm taking here NaHCO3, sodium hydrogen carbonate, that is metal hydrogen carbonate, sodium hydrogen carbonate, we can call it as sodium bicarbonate also. Okay, right. Now what happens here? Same products, salt, right? So salt, how to write the salt? Na is there, Cl is there. Okay, so NaCl, H, and here one H, from here one oxygen, H2O, one hydrogen, second hydrogen, from here one more oxygen, that is two hydrogen and one oxygen, H2O. After releasing oxygen from CO3, CO2 will be remains. Then carbon dioxide gas also released. How to identify the carbon dioxide gas? Again pass the carbon dioxide gas into the lime water, that will changes into milky white. That indicates, the changing of milky white indicates what? Presence of carbon dioxide gas. Okay, so that is what acids reacting with the carbonates and metal hydrogen carbonates, and the products are what? Salt, water, carbon dioxide. In both of the when acid react with metal carbonates and with metal hydrogen carbonates also, the products are same. Okay students, so if you like the video, subscribe the channel, like the video and share it and press the bell icon. Thank you.